In this PowerPoint, I will be discussing EDTA titrations. EDTA is a compound that forms complexes with many different metal ions. It is considered a chelating ion because it binds to the metal from more than one atom. Compared to monodentate ligand, which only binds to the metal from one atom, a chelating ligand is more stable. In the example below, you can see that the two nitrogen groups of the EDTA binding to the calcium ion. EDTA is a hexaprodic system, which means it can donate 6 different protons. Since EDTA is hexaprodic, we can calculate the fraction of EDTA in each of its protonated forms. The fraction of EDTA in the Y4- form can be given by the equation the fraction of Y4- equals the concentration of Y4- over the concentration of EDTA. EDTA is used to titrate with many different elements. In this general example, a metal M with a charge of N reacts with Y4- at equilibrium to yield My with a charge of N-4. With this chemical equation, we can create the formation constant equation, which is Kf equals the concentration of My with a charge of N-4 over the concentration of M with a charge of N times the concentration of Y4-. Note that the EDTA is being represented as the Y4-. Since the fraction of Y4- equals the concentration of Y4- over the concentration of EDTA, we can rearrange this formula to make the concentration of Y4- equals the fraction of Y4- times the concentration of EDTA. We can then substitute this into the value of Y4- in the formation constant equation like so. Kf equals the concentration of My with the charge of N-4 over the concentration of M with the charge of N times the fraction of Y4- times the concentration of EDTA. After some more rearrangement, we get the conditional formation constant Kf prime equals the fraction of Y4- times the formation constant, which equals the concentration of My with the charge of N-4 over the concentration of M with the charge of N times the concentration of EDTA. In this example, we are given the formation constant of Ca(Y2-) and the concentration of Ca(Y2-). We need to figure out the concentration of free Ca2+ in solution at a pH of 10. First, we write the chemical equation. Calcium 2+ plus EDTA at equilibrium yields Ca(Y2-). Now, since we have a metal ion, EDTA, and the compound of EDTA with the metal ion in our equation, we need a conditional formation constant, whose equation is Kf prime equals Kf times the fraction of Y4- in the solution. The Kf given in the equation is 10 to the 10.65, and the fraction of Y4- at the pH of 10 is 0.3. When multiplied together, we get a conditional formation constant of 1.3 times 10 to the 10th. Now we need an ice table. We have no initial concentrations of Ca2+ and EDTA, and the Ca(Y2- initial concentration is 0.1 molar. At equilibrium, only a certain amount of Ca(Y2- dissociates into Ca2+ and EDTA. This number is represented by X in the ice table. With the values from the ice table, the conditional formation constant, and an equilibrium equation, we can find the concentration of Ca2+. At equilibrium, the conditional formation constant equals the concentration of Ca(Y2- over the concentration of Ca2+ times the concentration of EDTA. When plugging in the values from the ice table and the conditional formation constant, we get 1.3 times 10 to the 10th equals 0.1 minus x over x squared. After all the calculations, we find that x equals 3.5 times 10 to the -4th molar, which is our concentration of free Ca2+ in solution.